Hello guys, we want to look at some questions under alternating circuit, RLC circuit, under purely inductive circuit, purely capacitive circuit, and purely resistive circuit, AC circuit generally. Now, number one says, in measuring high frequency AC, the instrument used in the dash: A, moving iron ammeter; B, hot wire ammeter; C, DC ammeter; D, moving coil ammeter. Now, what we are going to consider here is that we have what they call the DC ammeter. According to the option that we have also mentioned, moving what? Iron ammeter. Now, these two are used to measure what? DC. Sorry, moving coil ammeter rather. They are used to measure what? DC current. And they use what? The principle of what? Or using what? Magnetic effect of current. Magnetic what? Effect of current. Of electric current. Basically, this one use force on a what? On a current carrying by conductor. Carrying conductor. That is flaming left arrow. So this one is moving coil ammeter. If you do not see this one there, basically it uses principle of force on the current carrying conductor. So that is what it is. We have what they call moving what? We have moving what? Iron ammeter. Moving what? Iron ammeter. Sorry, let me change my marker. Moving iron ammeter. Moving iron ammeter. And we have what they call hot wire ammeter. Hot wire ammeter. So the two of them can measure what? AC. I don't want to waste too much time. AC and what? And DC. But this one use what? An ideal what? Instrument for what? Measuring what? AC. At what? At high what? Frequency. That is what? Hot wire ammeter. Now, moving iron ammeter used to measure of AC current at low frequency. This one is for what? Low what? Frequency. Don't forget that hot wire ammeter uses what? The principle of thermal expansion, making use of what? Heating effect of current. It makes use of what? Heating effect of current by what? Principle of thermal expansion. But the two of them can measure both what? AC and DC, but at high frequency, low frequency. So I've explained that. Now the option says what? In measuring high frequency AC, the instrument used in the dash. The instrument used is dash. A, moving iron ammeter. B, hot wire ammeter. The answer is what? Hot wire ammeter. Option B. We cannot use moving iron ammeter. D is DC ammeter, which is also known as what? Moving coil or galvanometer when short is connected in parallel. So that is DC what? Ammeter. Then we can use what? Moving coil ammeter for measuring DC too. So that is the answer is B. Let's go number 2. Says what? In alternating current theorem, the unit of impedance, RMS voltage, and resonance frequency are respectively equal to dash. Now, the unit of impedance is measured in what? Ohms. RMS voltage is measured in volts. The frequency, resonance frequency is measured in hertz, are respectively equal to dash. A, voltage, ampere, and hence. B, ohms, volt, and hence. That is the answer. C, watt, ohms, and no. D, ohms, hence, and joules. No. The answer is ohms for impedance, volt for what? RMS voltage, and hence for resonance frequency. Number 3, he said in AC circuit theorem, the root mean square current, IRMS, and the peak what, which is maximum current I naught, are related by dash. Are related by dash. They said in an AC circuit theorem, the root mean square what, IRMS current and the peak maximum current I naught are related by that. Now we know that the formula for what? We are in number 3, don't forget. The formula for what? For relationship between them is what? IRMS is equal to I naught over root 2. Then VRMS is also equal to V naught over root 2. Similarly, we can write that I naught is equal to what? Root 2 IRMS, which is saved as 1.414 IRMS. So you can write this one like this, a relationship, or this. We can see write this one as IRMS, this I naught, sorry, is equal to what? 0.7071. 1 over root 2 is 0.7071 I naught. So anyone we are talking about, you can repeat it, you can replicate it here without wasting much time. So we have option A, we have I naught equal to IRMS over root 2, wrong. B, IRMS equal to I naught over root 2, correct. C says what? IRMS equal to what? 1 over I naught root 2, wrong. D says what? I naught equal to 1 over IRMS root 2, no. The answer to that question is what? B, IRMS equal to I naught over root 2. B is the answer, which is this one. Let's go to number 4, which you have to draw diagram. They said in the series what? AC circuit. Let me draw the diagram first. Now we have to look at the diagram. They said in the series AC circuit shown below, that is this, okay, the potential difference across the inductor is 8 volts, and that across the resistor is what? 6 ohms. Yes, 6 volts rather. And that across what? Resistor is 6 volts. Okay, the effective voltage is dash. Effective voltage V is dash. We have to calculate this V. Now this is what? An RL circuit. So since it's an RL circuit, the general formula I gave in my classes is what? VR square to VL minus VC all square. Since what? Since V what? C is not given, capacitor is not given. So we are in the circuit, so we are going to assume VC is equal to 0. Therefore, the formula becomes V equal to what? Square root of what? VR square plus what? VL minus 0 is VL all square and VL square. That's the way I do my thing, so that you can know, you can reduce number of formulas you can. So this one will be what? To put on your head. So this one will be 8 square because VR 6 volts. So it is 6 volts. This is R and this is L. So what about what? VL is 8 volts. So play with is 6 volts square plus what? 8 volts square. What do you have? You are going to have 36 plus 64, which gives us 100. Square root of 100 is 10 volts. So the answer to that question is what? 10 volts. We have option A, 2 volts, B, 10 volts, C, 14 volts, D, 48 volts. So the answer is B, 10 volts. Now, let's say which of the following graph, I want to also draw diagram here, shows the correct vector diagram for the circuit below. Now, they said what? According to the question, they said which of the following graph shows the correct vector diagram for the circuit below. This is a circuit. Looking at the circuit carefully, you will discover that it is what? An RL circuit. Now, an RL circuit is a circuit that shows what? Resistor inductor circuit. Now, since it's an RL circuit, what I will advise us to do is what? Look at the vector diagram. This one now, VL is showing different circuit because VL cannot be what? Option A is showing different circuit. These are the options. This one is going towards the what? Positive X axis. Now, the normal vector diagram is what? Look at it. This is VR. This is VLC. this VL. This is vector diagram. Then this it depends on what. If it's what, if VL is greater than VC, the what it will fall here. That means you consider that one. That is a case of what, this one now, which is this one. Option D is the answer. Then if it's a case of what, VC is greater than VL, then it will be like this. Look at the board. Let me reduce diagram. It will now be like this. So this VR will now be what, VL. So in this case, this one has go half. This is the vector diagram. If what, VL is greater than what, VR. This one is what, when VC is greater than what, V what, what do you call it, L. Although you can draw the complete diagram, but if the two of them are not the same, if they are equal, it will just be like this. Only VR will be considered because VL and VC will cancel out. Don't forget that the two of them are 180 out of phase, so the answer is D. So go and watch my video on that so that you can understand what I'm saying. The next question says what? Number 6. It says in the AC circuit that contain only a capacitor, the voltage lags behind the current by dash. A, 90 degree, C, 180, B, 180, C, 60 degree, D, 30 degree. The answer to that question is 90 degree or pi over 2. Number 7. Number 7 says when an alternating voltage is applied to a capacitor, no power is consumed because the current and voltage are what? Power is what? Is no power is consumed when it comes to what? A capacitor. No, because now the capacitor current lead voltage. Because for power to be consumed, don't forget current and voltage must be in what? In phase. So that is major reason why no power is consumed both in inductive circuit and purely capacitive circuit. So it's because what, in a capacitive circuit current leads voltage. A says what? Current and voltage are what? You say because the current A and voltage are 180. B, and the current and voltage are in phase. No. C, the current lags behind the voltage by 90 degrees. D, current leads voltage by 90 degrees. Yes, that is the answer. So D is the answer. Number 9 says what? Number 8 rather, sorry. We said what? When a certain AC supply is connected to a lamp, it lights with the same brightness. That means they have the same resistor. For the lamp is acting as a load, which is having what? The same brightness, meaning they have the same resistance. Okay? And when DC and AC, whatever the current DC will measure will be the same current that AC will measure, provided they have what? At the same resistor. According to the definition of root mean square root mean square value. He said what? Root mean square value or root mean square current is the current or the steady current that measures the same current as that of what? Of an AC. The steady current that measures the same what? Current as AC, provided what? The resistance are the same. You understand me now? That's what he's saying. So isn't they have the same brightness? They say what? Light with the same brightness as it does with a 12-volt DC battery. The RMS value of the what? Because the 12-volt this battery is a steady voltage, and the light up at the same brightness means that they have the same resistor. So the RMS value of the AC supply is also what? A. Its supply is dash A 8 volt or 8.5 volt, B 17.0 volt, C 3.5 volt, D 12.0 volt. The RMS voltage will be the same as the 12-volt battery voltage because they are operating at the same resistor. Don't forget the lamp, they light up the same way. They have the same brightness, meaning that the same resistor, so they will have the same voltage. So the answer is D, 12 volt. Let's go to number 9. He said the instantaneous value of the induced EMF as a function of time is dash, okay, where E naught is the peak value of the EMF, The instantaneous value of the EMF, 1/4 of the period is dash. Now, there is a question here we have to look at. Very important. Very, very what? Important. Now, he's saying that what? Look at it. We have what? Instantaneous what? Voltage got to what? Sine what? Omega t. Now, what he's saying is that what? The instantaneous value of the induced EMF as the function of time is defined as what? This. Where E naught is what? Peak what? Value of the EMF. The instantaneous value of the EMF is what? 1/4 of the period is dash. 1/4. 1/4 means 1/4 of the period. 1/4. Period is what? 360 degree. Don't forget, one period is what? A circle. And a circle is what? Angle a circle is 360 degree, which is going to give us what? 360 what? 1/4 of 360. That means times 360 will give us what? 90 degree. So in that case, our phase angle W theta, which is phase angle, will be equal to what? 90 degree. So I will replace this one with what? So that means instantaneous what? EMF value is equal to what? Peak what? EMF value sine what? 90. I will now replace this one. WT is what? Is I will replace this at what? 90 degree. Sine 90 is equal to 1. Therefore, instantaneous EMS value is equal to what? The peak EMS value. So we are going to have option A. We have what? A is equal to what? They said what? The instantaneous value of the EMF 1/4 of the period is dash. 1/4 instantaneous value is equal to what? E naught. A, E naught. B, E naught over 2. C, E naught over 4. D, 0. The answer is E naught. Number 10 now. We have 2 more to go after this. He said from the diagram below, I have to draw diagram. If the potential difference across resistor, capacitor, and inductor are 80 volt, 110 volt, and 40 volt respectively, the effective potential difference. So let's draw the diagram first. From the diagram below, if the potential difference across the resistor, capacitor, and inductor are 80 volt, 110 volt, and 40 volt respectively, the effective potential difference is dash. So we are looking for what? The first one, they say what? The potential difference across the resistor, accordingly, the way they arrange is what? 80 is 80 volt. Across the capacitor, the way they are arranged is 110. Then across the what? The resistor, the inductor, which is the last one, is 40 volt respectively. The difference, what? The effective potential difference. So what I'm going to do now is what? Using our formula. This is formula V what? Is equal to VR square into what? VL minus VC all square. Let's play with it. Let's play with it. This one 40 what? Now 40 square plus what? Into bracket what? VL is okay, VR is 80 square, sorry. This is then VL is what? 40 minus what? VC is higher than VL, so that means current is leading in this case. Or what? Square root of everything. So this one give us what? 80 square plus what? This one give us what? Minus 70 all square. So this one give us 1600. No, 6400 rather. Plus what? This one give us 4900. So 4900 plus 6400 will give us what? 313. Carry 1100. That's what I would have. That is the square root of this. Now, square root of 20 is 10. The square root of 113. 113 is about that's about 10.6. So this 10.6 times 10. Because 113 times 1 square root is 100. 20 is 10. So 106 will now be V. So That is 106 volts. Now let's look at option A says what? 116.3 volt. B says what? 50.0 volt. C says what? 230 volt. And D says what? 106.3 volt. Yes, that is the answer. D is the answer. Number 11. In an AC circuit, the ratio of the RMS value to the peak value of current is dash. Now, the ratio of RMS value to the peak value is dash. The ratio, when we talk about ratio in physics, we are talking about the ratio of what? RMS value to the peak value is dash. Now, we know that RMS value is what? Or current is equal to peak current over root 2. So in that case now, if I divide both side by or multiply both side by peak current, 1 over peak current, let multiply both side by 1 over peak current, so that I have ratio of RMS value to peak current. This will cancel this. What I would have, IRMS over peak current is equal to what? 1 over root 2. If this one is not there, you can rationalize how 1 over root 2 times what? Root 2 over root 2. That will give us root 2 over 2. If this one is not there, this one will be there. So let's look at the what? This is the ratio now. Ratio of what? Of IRMS and to peak current. They said what? In AC circuit, the ratio of RMS value to peak what? Value of current is dash. So the answer A says 1 over root 2, B says root 2, C root 2, ordinary 2, and D says what? 1 over 2. So the answer is what? 1 over root 2, which is option A. Now let us look at the last question for this section, which is number 12. Now they said what the last question for this section. They say which of the following is the correct shape of graph of the graph of capacitive reactance XC versus frequency F for a pure capacitor in an AC circuit. We have option A, we have option B. This one is what? Is not the diagram. This one is showing for purely inductive circuit. If it is what? XL now, against frequency, this one will have been correct. So this one is wrong. Let us go to option B. It cannot be straight. It's going to be what? A little curve. So this inverse. I know it's inverse because the relationship between the what? XC and S and frequency is inverse proportionality, but it's not like straight like this. It must have from little a curve. You understand? So that is it. So C. Now C, B is wrong. Then let's look at C. No, this one is wrong totally. Then D is what? Is correct. This is XL, SC against what? Frequencies. D is correct because relationship between them. Don't forget your graph of XC against frequency is what? Like this. Then frequency XL, inductive reactance against frequency is like this. So don't forget the two graphs. You understand? That is very important for you to know. So that is just that. Go and watch my video on AC RLC circuit so that you can get more information and get to understand more things about what RLC circuit. I believe you enjoyed the first session of this series of this particular question and answer section of RLC circuit. Thank you very much for watching. Thank you for subscribing and thank you for liking my video. Thank you for commenting. This will all this go a long way to encourage us to do more. Thank you very much. God bless you.